Hello all, welcome back. So in this video, we are going to understand how can we create a tiny URL. Okay, how can we design a system for tiny URL? So what is tiny URL? So let's say there is a website like www.amazon.com slash a lot of things. Let's say there are 200 characters. It's very inconvenient. So what we can do, we can just say www.tinyurl.com slash 1234. Okay, this is a short URL for very large URLs. Okay, so let's see what are the system requirements. What is the problem statement basically? So the first problem statement is we are going to generate URL which are unique. Okay, so it can happen. Let's say we have URL 1, we have URL 2. Okay, and by some problem, both got assigned tiny URL slash XYZ. Then it will be a conflict, right? Either we have to delete this or we have to delete this, or like there is a conflict and this is not good. Correct. Okay. And the second thing is for per URL, we have want to see like how many clicks we received. So like we know machine learning and all those things are the new era. We want to see like how many click we are getting for each URL. How popular is this? So this is the second thing. Okay. Now going to the performance consideration. Yeah. So for going to the performance consideration, in this design, we want to support 1 trillion short URLs. Okay. So there should be 1 trillion unique short URLs. Second thing should be each URL, we are assuming that on average, a URL will be clicked 10,000 times. Okay. And the popular URL will be clicked 1 million times. Okay. Let's not take this point number 4 as of now. We can discuss it at the end of the video. Okay. And we are also assuming, not assuming actually. So let's say you are a user. Okay. You will only generate a tiny URL once for your website, right? Only once. But that URL, let's say this tiny URL, okay, it will be accessed multiple number of times. So what we can say, read is much higher than write. Correct. So that is what we have written. The read is much higher than write. So what are the APIs? What can be the API? One is generate URL. Correct. What all things generate URL should have? It should have actual long URL. Okay. It should have actual long URL. Then who created the long URL? So user ID. Correct. User ID should be there. And when is the URL is given for generation? So timestamp. Okay. So this is the like MVP. This is the thing which we actually need. This should be 100%. And the matrix one we can see later on. Okay. Now for the generation of the tiny URL. So let's say this is the tiny URL. Okay. And X, Y, Z, 1, 2, 3. How long this should be? How long this should be? Okay. So what we have seen said that we want to support minimum of 1 trillion short URLs, right? So in each of this character, how many numbers can be there? I mean, how many possibilities are there? So we have A to Z, correct? We have capital A to Z, and we have 0 to 9. Okay. So there are, as we know, like there are 26 characters. Okay. And here also we have 26 characters. Okay. And here we have 0 to 9, which is 10. Okay. So even if we don't take this, if we just take this one and this one, we are getting 26 plus 10 equals to 36 characters. Okay. So if the length, this length is approximately 8. Okay. So what we can say, 8 to the power 36. it will be much larger than 2 trillion or somewhat near 2 trillion. So I think this is okay. So what we have decided, that tiny URL slash 8 digit 1 2 3 4 5 6 7 8, and this characters will be from A to Z small and 0 to 9. Okay. Now, while creating this string, okay, there can be like collisions. Like there will, so for example, there is a user, okay, who told our system to like create URL. It can happen, right? That two URLs, let's say URL1 and URL2, both gets same hash. Let's say XYZ. So what should we do? uh, we can either like create a linked list. So what we can do, like if let's say this is XYZ, we can create a linked list like this, like this is URL1, this is URL2, URL3. Okay. But normally we have seen that in DB this creation of linked list is not supported. Okay. So what we can do probing. So what is probing? So if like we don't need this. So if URL1 got XYZ and URL2 also got XYZ, so what we can say URL2, that you go to XYZ plus 1. So this is URL2. Okay. So this is what we can do. So although we have seen that read is much larger than write, but still we will try to optimize write so that we can do it fast. Okay. So what are the challenges? So this is the first challenge. Okay. So let's see, should we take multi-leader DB or a single leader DB? Okay. So let's say if we are taking multi-leader DB. Okay. So this is DB1, this is DB2. Okay. And let's say here is very big person. Let's say Ambani. Okay. Ambani, he is like top 5 richest person in this world. Ambani. Okay. And here is, let's say me. Okay. Me, Akash. And I have, so Ambani, let's say in DB1, he put some like very big presentation, let's say uh, uh, financial year 2026 plans and everything. And the tiny URL he got is, let's say 1234. Okay. At the same time, after, let's say this is leader one, right? This is stored in DB1. After some time, before they started syncing, so this is T1, me posted some rubbish URL, let's say pornhub.com. Okay. And I also got 1234. Okay. So this is T2. They synced they synced after some time, let's say T3, they synced as T2 is after T1. So what happened? That 1234 got replaced by pornhub.com. Okay. Now Ambani went for a presentation, and when he went to client, pornhub.com started opening. That is very bad, right? So we really need to make sure that there is no conflicts. So if we want to need to make sure that there is no conflict, it is always good to have a single leader replication. So this will be the single leader. Others we can use for read, but all the write should go for leader. uh, Leader, follower, whatever, follower one, follower two. Okay. So let's go for single leader. Okay. Now for the read, let's see, can we do caching? Can we do caching? Okay. So there are many kinds of caching. What kind of caching can we do? Let's say this is user. Okay. This is your DB. There is another user. Okay. During write, can we do caching? So as we know, during write, if we do caching, the write will be extremely fast. But the same problem will arise. I did some operation, this caching, like Ambani. Okay, Ambani gave some URL. He got 1234. Okay, this is T1. Same, he did I did pornhub.com. I also got 1, 2, 3, 4. Okay. After some time, they synced with the DB as T2 is bigger than T1. So 1, 2, 3, 4. So 1, 2, 3, 4 is replaced by pornhub.com. Okay, which is bad. So no caching during writes. Okay. Now the third thing is, can we do partitioning? Partitioning also increases the speed significantly. Okay, so partitioning. Okay. Uh, so we already know by a hash function, we are getting the tiny URL like 1, 2, 3, 4 or XYZ. So if we just do partitioning using the hash function and we just sort them out, it will be very easy, right? Like 1, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, 6. It will be extremely fast and the partitioning can be like this. Okay. So if we want a like particular URL, let's say 1, 2, 3, 5, we know we can get it directly from here. If some another user, let's say here is 2, 4, 5, 6, 2, 4, 5, 7. Okay, another user wants 2, 4, 5, 7, 2, 4, 5, 7. We can go to this one. So all the load is not in one node. The load is distributed. Correct. And also there is no problem of hot points. Why? Because like this are hash this IDs are created by hashing, right? So they will be anywhere random. Not all the YouTube videos will go to one place, not all the Amazon videos will go to one place. It will be distributed. Correct. And for partitioning we can typically use consistent hashing. Okay. Okay. So how the database schema should look. So DB schema should something look like tiny URL. Okay, tiny URL, then actual URL. Okay, then sorry, I'm running out of space, so I'm just writing one after another. User ID. Okay, timestamp when it is created, and expiry timestamp also maybe. Created timestamp, expiry timestamp. Okay, and also number of clicks. So as many time the click has been done, we will increment it by 1. Okay. Now let's say two users are creating URL at the same time. Okay. So our DB is like this. Okay. Uh, let's say here is already one URL. I'm not filling all the data. Let's XYZ. Okay. Amazon, something blah blah blah. Okay, and here two users are trying to create a URL. Let's see user 1 and user 2. Who should get the log for this particular row? Okay, how can we decide that? Either we can do predicate log. Okay, so what predicate log does is that it logs a row which doesn't exist yet, or we can materialize the log. What is materialized log? Let's say we have create XYZ1 and every of this are null pointers. Okay, every row columns are null pointer. Okay, in materialize log, it will do, it will just create a column and lock it. Okay, and second guy will also create a column and lock it. Okay, they will create separate columns because like there is no value yet. Once they commit the value, then this null pointer, I mean this null will be changed via the actual value. Okay. Now, what kind of DB should we use? Okay. Another thing is like, do we need range queries? Okay. Do we need range queries? Mostly no. Why do we need range queries? We are not searching like all the links from A to let's say C, right? We are not searching that. So what we can use LSM tree. Okay. We can use LSM tree. You can refer my system designing videos like what is LSM tree. Okay. And SS tables. Okay. These are in hard disk. Okay. And this is in memory. Okay. This is in memory. So whenever read is coming, what it will do, it will first go to memory. So this search is extremely fast. Okay, if it doesn't find it here, then it will go to hard disk. Any recent writes will be inside this LSN tree. So, or we can also use B trees also. That is perfectly fine. Basically, the motive is the read should be extremely fast. Correct. So, which DB takes care of all this thing? So we should have a single leader. The partitioning should be there. We can either use LSM tree or binary search tree, binary tree. So the good DBs which we know is either MySQL or MongoDB. Okay, we can take any one of them. I will go with MongoDB. Why? Because in MongoDB the read is bit more faster than MySQL. The typical property of SQL versus non-SQL, you can find it inside my system designing lecture. Okay, so now we will see how can we increase the read speed. Okay, so first is replication. Uh, what kind of replication should we use? So we have already decided it will be a single leader. So this is leader, this is follower. Okay. So if there is multiple follower, the read will already increase. The read speed will increase by like different user can go to different replicas. Okay. So that way the read speed will increase. Okay. Now the problem is, what if let's say at time t1 someone created a website, let's say amazon.com, which is in xyz, and to sync it takes 5 seconds. Okay, it takes 5 seconds, but in third second someone went to a follower and tried to read xyz, he won't find that, which is a bad news, right? So what we can do, we can say that, hey, for some amount of time, let's say for 6 seconds, if there is a new write, go to the leader. After 6 seconds you can go to followers. Okay, because like for 5 seconds it will take like approximately 5 seconds to replicate to all the followers. Okay, second thing, can we do caching? Can we do caching? So there are like caching ways we should see before we say can we do caching or not, and which kind of caching. So we have already decided while writing we won't cache. While writing to db, we won't cache because this can create conflicts, right? So what we can do, we can say, hey, write directly to the DB, okay, and then put it in a cache. So any other person who is trying to read, he can read from cache. Okay. So in this way, there will be no probability of like conflicts, and the read will also increase significantly. I mean, the read speed will also increase significantly because of the cache. We can use either LRU, recently used, or least frequently used. That is completely up to the website. LRU is very easy to implement. Let's take LRU. Okay. So what I just told about caching is written here. So same thing. Okay. Now let's go to the problem statement 2. Okay. So problem statement 1 is generate unique URL, and the problem statement 2 is like for analysis kind of thing. We want to see like whatever the spelling is. We want to see that how many times a link has been clicked. Okay. Okay. So problem number 1. Okay. Let's say this is the DB. This is user 1. Okay. U1. This is user 2. U2. And a particular link, let's say XYZ, is already clicked 100 times. Okay. Now the both of the users are clicking the same URL at the same time. Both are clicking T1 time. Okay. So it here it should be +1, here it should be +1, but as they received at the same time, it only incremented by 1. But so the actual result is 101, but it should be 102. So this is wrong, correct? So we have to take care that this doesn't happens. Now the second thing is, do we like really need to update all the plus ones at the real time? Because let's say this is the DB and 10,000 people are clicking the URL. Okay, 10,000 persons are clicking the URL. Updating the DB like 10,000 time in 1 second, it will unnecessarily increase the load on the DB, right? So what can we do? We can do is we can put a message broker in between. Okay, we can put a message broker in between. Okay, every plus one, it will go to the message broker and message broker will update the DB. Now, what kind of message broker should we use? Should we use like should we update all the information directly to the DB? Plus one, plus one, plus one. Unnecessarily the same problem, the DB is getting overwhelmed, right? So what we can do, we can update the DB in batch. Okay, so we can update the DB in batch. Okay, so like this will do once a URL has been clicked for 10 times, then only I will go and update the DB. Okay, or after some time, let's say after every 10 seconds, I will update the DB. This way, what is happening that DB is not overwhelmed. Okay, now what kind of message broker should we use? Okay, so there are two kind of message broker as we know. One is Rabbit MQ and second is Kafka. Which one should we use? RabbitMQ is extremely fast. It is extremely fast, whereas Kafka is bit slow because it persists the data. Okay, but do we actually need extremely fast plus ones? No, because anyway we are batching so that DB doesn't get overwhelmed. And the problem with RabbitMQ is also that if somehow it goes down, all the data is lost. But in Kafka, this problem is not there. So we will go with Kafka. Okay. So now who will like compute? So like I told that this will be a DB. Someone will be there who will like every 10 second or every 10 clicks it will update. Here is our Kafka and every plus one will come from here. Right. Who is this? Let's take Flink. Uh, Flink will do all the computation. It can do real-time computation. So Flink. Okay. Other than Flink, we could also have used it like Mapper or Sparks, correct? But why won't we use them? Because they are extremely costly and like they can't do real-time processing also. So yeah, let's go with Flink. Now the last part is how can we delete the expired links? We can use Tombstone. So let's say this is our DB. There are two threads. One is for inserting, okay, and there is another thread for deleting. Okay, every like let's say 10 second it will run. It will see all the DBs which all the entries which are like threshold minus 10 second. Okay, and it will delete all the entries. We can use a tombstone thread. Okay. Okay. Now let's go to the final designing. This can be a little bit different than what I'm showing. So we have our user. Okay. We have load balancer. Okay. And then there are the services for generating the URL. Generate URL. Okay. This will directly push the information inside MongoDB. Okay, which will be a single leader kind of MongoDB. Okay, this is our DB. Okay, and for analysis, what we can do every time a person clicks, like we have told that we will send it to Kafka. Okay, the event. Okay, there will be a service. Uh, there will be a service plus one click service, whatever the name. Okay, it will send the events to Kafka. Kafka will store it in Flink. Flink will process them. Okay, and once Flink have like let's say 10 second or every 10 click, it will send it to DB. Okay, so yeah, and obviously here will be a load balancer. So this is the final designing of TinyURL. Okay. Uh, cool. So this is how we can, like, this is a top view of how can we generate system designing for the tiny URL. Thank you.